video, I will be explaining an application problem of differential equations. This will be a very simple, ordinary linear differential equation. The problem says, assume that an investment grows at a continuous rate. If the initial deposit was 1,500 and after 18 years this amount has grown to 4,500, find the growth rate constant, and I will be explaining what is this. And second, what is the value of the investment after 25 years of the initial deposit? So we have two questions, and for solving this we need to know that we have information actually about the rate of change of the investment. The rate of change of an investment depends on the amount that you have in the investment. So it's proportional to the amount in the investment. And that is what I'm going to use. So remember, it's two variables are proportional. One is a constant multiplied by the other. So it means if I say that the rate of change is proportional to the amount, to the quantity, let's call the quantity Q. So means that the derivative of Q with respect to T, so the rate of change of Q respect to T will be K multiplied by Q. So K multiplied by the quantity. So I'm going to type in this way. The rate of change of the quantity is proportional to the quantity. See, that's what I'm telling you. So the rate of change of the quantity is the derivative respect to the time. This is the rate of change of the quantity. And it's proportional to the quantity means that is the quantity multiplied by the constant. This is the constant that we call constant of proportionality. But in this case, when we are speaking about growth, we call the growth rate constant. So this K here will be the growth rate constant. This is the first question. Find this K here. But we are taking into account that the rate of change of the amount in the investment is proportional to this amount. If the amount in the investment is a big amount, it will be increasing faster. So you have more money, you are going to get more from the investment. So that means proportional. So this is the differential equation that we're going to solve. For solving this differential equation, and this differential equation is very simple, you can separate the variables. So you can type dt here and we can divide by q. So we can say that the q over q equal k dt. So we have separate variables. And now that we have this, we can use integration. Integrate both sides of the equation. So we have the integral of the q over q equal k by the integral of the t. Obviously, this k is a constant, so can be written outside of the integral. And these are two simple integrals. The integral of the q over q is the natural logarithm of the absolute value of q. But q is always positive because you're going to have a positive amount. So we don't need to type the absolute value. So we can say that the integral of the q over q is the natural logarithm of q. And this integral of the t is just t. So we can write then that the natural logarithm of q equal kt. And obviously we need to add a constant of integration plus c. So this is the solution of the two integrals. But obviously to solve a differential equation is finding the dependent variables in terms of the independent variable. So q in terms of t. So we can solve this equation using the inverse function for the natural logarithm, that is the exponential. So q will be the exponential of kt plus c. So I'm going to type here then that q equal the exponential function of kt plus c. And remember, again, remember the first question is find the value of k. And we have some information, but let's simplify this expression. So remember, if you have in the exponent a sum, actually what you have is a product of two powers with the same base. So this is the same of a to the power kt multiplied by a to the power c. So q will be a to the power c multiplied by kt. Obviously, if you multiply these two powers, because they have the same base, the answer will be the same base e and adding the exponent kt plus c. So this expression is the same of this. And I type in this way because you will notice that e is a constant, 2.71828 approximately, and this c is another constant, so this e to the power c is just one constant. So you can type this q equal a constant, let's call it m, and then q will be equal to m multiplied by akt. So I'm going to type q equal m e to the power kt. So now we have an equation in which there are things that we don't know. We don't know m now. There is another constant. This constant is coming from this constant of integration. This m is actually e to the power c. And we have here the constant that we have as a question. What will be the value of k? And actually we have information to help me to find m and to find k. What are the information that we have? We know that the initial deposit was 1500. So that means when t was 0, so the initial deposit when t was 0, q was 1500. So we have information when t equals 0, q equals 1500. This produces one equation here in which we have only two unknowns, m and k. That is one of the questions. And here we have another situation after 18 years. So when t equals 18, the amount has grown to 4,500. So when t equals 18, q equals 4,500. That will give me another equation. So we get two equations with two unknowns, and we can get the two unknowns. See, this value of q is the value of the investment at any time. And we know that when the t equals 0, q was 1500. So I'm going to make this substitution. If t equals 0, q equals 1500. So that will give me, I can put the 0 here, I can put the 1500 here, and I get that 1500 equal m e to the power k multiplied by 0. But k multiplied by 0 is 0. E to the power 0 is 1. So actually we can write m equal 1500 because this is 1, e to the power 0. So m equal 1500, and we have a value for m. So the value of the investment is at any time will be q equal m e to the power kt. So and will be this m is 1500. So we know now that the equation for q can be written q equal 1500 e to the power kt. This is the value of the investment at any time. We are close to find the value of k, that is the question, because the only that we need to do is just make now the other substitution. If t equal 18, the value of the investment is 4,500. So if t equal 18, the value of the investment is 4,500, and I can use this in that equation and can find the value of k. Let's do it. So we can get 4,500 here, 4,500 equal 1500 e to the power 18k. And you have make substitute t by 18, the value of the time at that moment. So use a calculator. Obviously here you can divide by 1500. This is 50, you divide by 1500, you get 3 here. 3 equal e to the power 18k, and then get the natural logarithm, because now you have the unknown is at the exponent, so natural logarithm of 3 equal 18k. So you are using now the inverse function for e, that is the natural logarithm. So natural logarithm both sides. Here you get natural logarithm of 3. Here you get the natural logarithm of the x of e to any power if that exponent. So now we have that k equal, you divide by 18 and you get that k equal the natural logarithm of 3 divided by 18. Use a calculator, natural logarithm of 3, divide this amount by 3, and you get that this is 0.061 rounded to 3 decimals. So you have answered the first question, the growth rate constant. For answering the second question, we have everything, because for answering B, what is the value of the investment after 25 years of the initial deposit? So now that we have K, we have the value of the investment at any time. So the real value of the investment at any time. So the value of the investment at any time will be Q equal 1500 e to the power 0.061t. And if I want to know what is the value of the investment after 25 years of the initial deposit, the only that I need to do is just substitute t by 25. So make this substitution, you get that if t equals 25, q will be then 1500 e to the power 0.061 multiplied by 25. Make this using a calculator or a computer or whatever software, and you will find that Q equal 6,000 around $6,892.72. This finished the explanation of this problem. I hope you have found it useful. Thank you.